All right. How many questions did I skip? 3? On the original assignment, I'm going to finish those 3 questions. Then finish the next assignment. So we need to do problems number 11, 24, and 43. Those are the 3 I'm going to do today. So, let's see here. That was funny. I can't even listen to music while I do it. Dang it. Also, what if I just simply can't do the problem because the download link is not even correct. But let's see. That was funny. So we need to skip to number 11. Now, number 11, 7, something, 12. You would think this one right here would be for number 11. Oh, yeah, that's right. There is a file for it. But the problem is that that I just couldn't figure out how to do the problem. That wasn't the problem. The reason I couldn't do the problem was because it was hard. It was a hard problem, pretty much. Like, that was the reason. So time for stuff. Let's see here.
Of 10 greater than or equal to 1.75. And
which problem are we on right now?
I've seen from my typing before, I'm pretty slow at that, so I'm actually going to just.
I need to find my place. She's doing problem 8.1 right now. So if I skip over here,
then the carpal tunnel gets worse.
Number 7, I believe, is I've already done number 7. I need to do number 11. Number 11 is the one I need to do.
That now we're going to need.
Hey, here it is. Here it is.
X's we are.
I need to figure out where the beginning of this is. All right, it's close to here, so I'm going to read the problem again. I tried doing this so many times, but I just couldn't figure out what I was supposed to do. So, oh, great. I just realized I have to rename the folder or file. 8.11. Yay! And you can easily tell that I procrastinated because I could have started my homework at like 11:30 or 12, but it's 12:46, so that's funny. Whoa! Ha 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 ha! Funny. Stop. Okay. Number 11. That was funny. Number 11. Number 11. I wonder what grade I'm going to get on our last test. I'm very curious to know what's going to happen for that. Let's see. I believe it's going to be here. So it's going to be right about here. here. I was so confused about how to do this. I spent so long trying to do this problem. Oh my gosh.
all the different parts of that.
I'm gonna have to turn the volume up here because I can barely hear anything.
So, I pointed out that the relevant population is,
Oh, here it is. Here's number 7. Oh wait, not number 7, number 11. Why is the text different?
I pointed out that the relevant population is all the customers arriving during the busiest hour of the day at this fast food operations drive-through. Okay. Then we did the calculation of the interpretation of it is this part here where I say,
I'm not going to bother like correcting my other problems because I don't know if she even really grades the homework. I think she just gives you 100% if you turn it all in. But anyways.
Number 11 and 12 are population or are confidence intervals for a total rather than for a mean. So a point estimate for a population total is represented with this equation where we call it T for total and give it a little hat to, okay, population total, however meant total.
Where she does the problem.
Total. If you take,
I was able to do number 12, but I couldn't do number 11 because it was completely different. It was not at all analogous to the other problems.
Use the relation to minus standard again. Error of exponential equations that just totally drove you nuts and your mind is now like, I hate you. Calm down. The problem is not that complicated and it's much simpler once we actually work it with numbers.
I'm so glad that the problem isn't complicated. Thanks a lot, textbook, for not at all preparing me for an easy problem.
So,
good job, textbook.
Don't freak out. We'll get through this together. All right, problem 11. The file P0216, we've looked at this one before, contains the number of arrivals at a turnpike booth for each of 4 5-minute intervals on each of 256 days. For this problem, assume that each column, such as arrivals from 8 o'clock to 8:05, is a random sample of all arrivals from the corresponding hour of the day from 8 to 9. Okay. So calculate a 95% confidence interval for the mean number of arrivals during each hour of the day. Okay. So we're taking a 5-minute sample and we're extrapolating it out to say how many arrivals are happening across the entire hour if this many are happening in 5.
And I really, really tried to do this problem and I just couldn't do it. Like, what is wrong with me? Why couldn't I do this problem? What was I doing wrong? What was I missing? I put some effort into this problem and I still couldn't do it.
As we see at the top, it's labeled for every 5 minutes. One of the first things we need to define is what is that capital N? That capital N in this problem.
Maybe I'll just do it instead of doing it on this separate tab. But there's not much room even if I get rid of this, there's still not going to be much room on this side. But I don't know, maybe it's fine. Maybe I can fit everything over here. Because sometimes it's more convenient to do it on the same tab as the other stuff because then you can just look at everything the whole time. But there's not much room over here. Okay.
Is equal to the fact that we are lying our estimate for a whole hour. An hour is 60 minutes. All we have are samples of 5 minutes. So how many 5-minute intervals are in 60 minutes?
Yeah, that's what I did. I did like a sample of one, like a sample of one out of 12. But that doesn't make sense. You can't have a sample of one. Because when I did the equation, the other equation where you have to take the sample size minus one, the number 0 doesn't work.
60 divided by 5 is 12. So big N is 12. There.
Okay, let's see how she does this because I tried that already. I tried n equals 12. But we'll see.
12 5-minute intervals in 1 hour.
Like I tried n equals 60 and sample equals 5. I tried n equals 12 and sample size equals 1. In this case, you would think sample size equals 1 because it's the sample.
Yeah, now we're going to need to calculate for our different values, our descriptive statistics like we did before. So from anywhere and on the data sheet, go to the data tab.
Oh, what are you doing? This is not what I was doing before.
To get this to work, just choose to.
What? What is that? Click anywhere. Click what?
So
I wasn't doing that for any of the other problems.
Anywhere and on the data sheet, go to the data tab.
I wonder if she was doing this for a bunch of the other problems too, and I just didn't know I was supposed to do that because it wasn't in our textbook. They didn't say anything about using the data tab. Are you kidding me? There's literally no way you could have known to do this without the video. There's no way. The textbook does not have anything about this. Where did you get that? How did you click that?
So from anywhere and on the data sheet, go to the data tab. You don't have to be in any particular location.
Where did she click? Where did she get that? I have no idea where she clicked just now. Data analysis? Okay, wait. This? Data analysis?
Location to get this to work. Just choose descriptive statistics from the data analysis toolpath. Click on OK. When that file opens up, our input range is going to be columns B, C, D, and E, 1 through 257.
How did you type that?
Opens up, our input range is going to be columns B, C, D, and E, 1 through 257. I selected that by holding the Shift Control down arrow key. And it selects all of the data that's contiguous or touching. Okay, make sure that labels in first row is checked off. I can't really.
You need it to be checked.
In cell D4.
Labels, you need to have the check mark. Wait.
Anywhere since D4 is part of the data range, so I'm going to go back up towards the top and plunk it down somewhere.
What?
Cell D4 anymore since or touching. Okay, make sure that labels in first row is checked off. I can't really put it in cell D4 anymore since D4 is part of the data range. So I'm going to go back up towards the top and plunk it down somewhere over to the right a little bit. In this case, H4, and
Wait, how did you do that?
data range, so checked off. I can't really put it in cell D4 anymore since D4 is part of the data range. So I'm going to go back up towards the top and plunk it down somewhere over to the right a little bit. In this case, H4. And I do want my summary statistics and my confidence level for the.
Dude. Like, what if this was the steps she was taking to solve the other problems, too? And this is like a shortcut to do every problem. No way, dude. No way. Like, how much time could I have saved if I had seen this video earlier? This looks like a shortcut.
You can see
No
that it
freaking
just
way.
is a jumble of stuff. I'm going back to the home menu.
How do you fix the formatting here?
To format and auto fit column width.
Oh, that's a nice tool. Hey, that's a new thing I learned. I never knew you could do that. Format. Where is it? Is it wait, hold on. Where'd you get that? Cells format? What? Oh, I'm stupid. It's right here. Auto fit column width. Well, that's awesome. You know what I'm gonna do? I don't want it on this tab because it doesn't fit on the tab. I had no clue we were gonna do this. Okay, cut and paste here. And auto fit. Nope, not insert. I hate how it lags, so it takes forever. There. That's pretty good there. Dude, that takes up so much space. I wonder if I should even have this as a separate tab. Because, like, we have number is 12 here. Number is 12. We're going to put N12 over here, but we might have to start another tab because this is so full. What on earth is this? This is a bunch of statistics about every single thing. There's the mean, standard, error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count, confidence level. Huh, that's interesting. Wow. That is not how I was doing every other problem, so.
And you can just stretch it way out across my entire table. And what Excel does here that annoys me immensely, and again, like I've told you, I am an anal retentive statistician, so I can't help it. But I hate that they did this and repeated these column or row headings over and over and over. It really is only needed once. I'm sure it's some coding issue and it was simpler just to leave it as is. But you'd think in this day and age, they could have this cleaned up and showing appropriately. So when you look at my solution file, the anal retentive side of me did clean it up. But for now, I am just going to move forward and pretend that I am not seeing this mess, and that I can just ignore it and show you that I can overcome my anal retentive side. All right. So one of the things that then we need to do is calculate that 95% confidence interval for the mean. Because what we're going to do is, after we've done it for the mean, mean for 5-minute interval, we're going to then go through and calculate it for the hour, the 60-minute interval, the hour-long interval.
What?
Right. Well, apparently even correcting misspellings is not working well for me. All right.
95 confidence interval for the mean for 5-minute interval. Okay, there's not enough space on this page. I could scroll down, I guess. I'm just going to move everything over to another sheet. This sheet will be what? Stats. And this sheet's going to be answers. Or something like that, because I'm going to be kind of working out the solution on this sheet of paper here. That's funny. Numbers 12. Numbers 12. I keep. We have data, stats, solution. So, 95 confidence interval for the mean for 5-minute interval. For the mean for 5-minute interval. That's awesome. Oh, man.
And we know we have an upper limit and a lower limit.
Upper limit, lower limit.
And as I said before, the main values that we need are these means and the confidence levels, bottom. So once we have those values, it's just a matter of simply adding.
Okay, so look at the mean. So look at the mean. And the confidence interval. And then do your equation, because I think you had to type some kind of equation there, but they already calculated an intermediate step. They already did an intermediate step for you, because in the calculation for the upper limit, you have to do part of your equation calculates the confidence level, and then the rest of the equation gives you the upper limit, and then but they already calculated. That's just my guess. I'm just going to see what she does.
Confidence level for the upper limit.
So oh yeah, that's so simple, because it's the mean plus the confidence level. So the confidence level there that they give you is the amount that you go above or below the mean. So they did the calculation for you. You don't even need to do all the complicated stuff. You just add the mean and you subtract them. Add it to the mean and subtract it from the mean. That's very, very simple. So, and you have to do that for all 4 things, dude. What the heck?
And that's way more decimals than we need, so I'm going to decrease the number of decimals to something somewhere reasonable. 2 seems reasonable. Now I could go through and do that over and over again for these other 3 columns, or I can just copy this over. I realize I'm going to get an error in the ones where it's copying for the words up above, so recognizing that that's just junk I don't need, I can delete it.
Okay, so maybe I should do it on the other tab, but my computer screen isn't very large, so I'd have to scroll down. I don't feel like doing that, so. Well, maybe I should do it there. Dang it. What is the solution, or what is the thing you're supposed to do? No freaking way. Like, what? Huh. Um. Stop it. Equals this plus this, enter, equals this minus this, enter, and wait a minute, did she do both of them at the same time?
More decimals down for other 3 columns, or I can just copy this over. I realize I'm going to get an error in.
She did both of them at the same time. It's a miracle. Hey, I want to delete both at the same time. Okay, can't we stop? We have 30.4, 29.0. We have like 2409, 2295, 1563, 1485, 15.15, 14.25. Oh my gosh. Oh my gosh. This is so funny. Here's what I'm going to do. I'm going to move these down here. Now this is better. What a waste of time. Oh my gosh. Oy, oy, oy. So, we got those. So those are the 5-minute intervals. Well, that doesn't make any sense because we still have to extrapolate it out into the full hour. Like this isn't really what the full solution, right?
Between 8 and 8:05, it's between 29.09 and 30.4, et cetera, et cetera. So the most arrivals at 8, the next at 9, followed by 10 and 11 being very similar in values. But now we need to extrapolate that 5-minute period out into the hour-long period for 1 hour interval. And again, basically, it's going to change then.
5 confidence interval for a 1 hour interval.
From 8 to 8:05 to 8 to 9.
So she's gonna just change it from 8 to 9, 9 to 10.
Right. And 9 to 10.
Oh, that's great. Here we go.
We know the to noon, we'll call it. All right. So we know the relationship there was up here that my n equals 12, right? Maybe I could move that down here and have it be more relevant. Oh, we'll just plug it in here. And we need an upper limit and a lower limit for our total.
Ooh. Ooh. So I forgot how to do this. Wait. If you do shift, maybe this works. Nope, that's not what you do. Is it control? Nope. I forgot how to move it. How to copy it and move it over. Is it like this? Oh. You push control and then you do that. Okay. That was funny.
So that's actually for total of the 1 hour interval.
For total of 1 hour. Oh. Well, I mean, there's no way that I could have gotten this from the textbook. So
all we need to do actually is calculate the upper limit times the n.
Take that number times 12. That's it?
Of 12.
Like, it wasn't using this complicated equations I was trying to use from before.
I added $2
Like, I was trying to follow the textbook. Like, she's probably going to do 12 entirely differently from how I did 12.
Limit, multiply it by...
What are you doing? Equals?
12, and again, make that a absolute cell reference by adding dollar signs.
What?
Oh, yeah. Well, if I could possibly.
What are you doing?
All we need to do actually is calculate the upper limit times the n of 12.
How did you do that? How did you add the dollar sign? What was that? How did you do that? And why do you need to use the dollar
signs? That to make an absolute cell reference. And then I'm going to do the same thing with the lower limit, multiply it by n of 12, and again make that a absolute cell reference by adding dollar signs. Oh, yeah. Well, if I could possibly. No, don't do that. Just get me.
I don't know how she added the dollar signs there. And why is that even necessary? Why is it necessary to add the dollar signs? I'm just going to see what happens if I don't add the dollar signs. I guess the reason is so that she can copy and paste it or something. Okay, I have no idea how she did that. How did you do that? How did you do that? F4? Is that it? You just push F4? And it's, of course my computer sucks because I have function F4. I have to push function F4. This times this function F4. So equals this times this function F4 and there. So like 365, 349, 289, 275, 187, 178, 181, 171. Are these the same throughout?
decimals that are needed, so I'm gonna lower that down to 2, and then I can copy that across. If you did not put the dollar signs on L25, which is where I put the 12 for big N, then you are not going to be able to copy across because you will get an error message. All right. So remember, every other column is garbage. Get rid of that. And so what ends up being stated here is the toll booth manager can be 95% confident that the number of arrivals, the average total number of arrivals for
Literally, all she did was calculate the number for the 5-minute intervals and then multiply it by 12. Like, it was that simple. Also, the entire process was completely different than what the textbook showed. It was completely different. So, that's awesome. That's just awesome.
From 8 to 9 is 349 and 360. 6, we would want to go up to the
I mean, what did the textbook want you to do anyways?
9 and 10 is 275 to 209.
There was nothing in the textbook at all about using the data analysis tab on Excel. Nothing.
For 10 to 11,
that made the problem way more simple.
To
You've got to be kidding me.
And from 11 to noon is 171 to 182. So that's how you interpret confidence intervals, and that's a confidence interval for a total. All right.
I wonder if she does the same type of thing for number 12. Probably. Like number 12, I did it the way the textbook told you to do it, and I was able to do it just fine, but I wasn't able to apply that same method to number 11. But let's see, if does she do the data analysis thing? Yep, she does. Yes, I wonder how much easier my question would have been if I had done that. Seriously, dude. Seriously. But anyways, well, at least I'll know that for the test. That was funny. So, we got our answers. Oh, I still have 5 decimals. I thought I pushed it down to 4 decimals. Okay, it's fine. So, data, stats, solution. So we have finished number 11. We only have 2 more problems, and then we have to do an entire other assignment. Actually, 2 assignments. And then we have to study for a test. Like, seriously, we have like a million things we have to do today. Come on. That was funny. (811) is complete. Close. We now need to do 824. She showed you the wrong. What? Did she change the numbers? She must have changed it, because there's no way I would have mistyped 24 and 43. There's no way. There's no way I would have mistyped that. 24 and 43, she has to have changed it to 21 and 40. There's no way. Like, what the heck? I totally didn't mistype that, because when I downloaded it a long time ago, well, I deleted them all, but still. What the heck? I did not mistype 24 and 43. She must have changed it in between when I sent this message and now. She must have changed it. So now maybe it's accurate. Like, maybe it was inaccurate before and now it's accurate. That's awesome, dude. Hey, look, she changed the due date for the assignment. She changed the due date. No way. She changed it to be due on the 14th. That must have been... She must have fixed the problems back then and then made it due on the 14th. I didn't even notice that. That's awesome. Look at that. Look at that. No way, dude. Yeah, she must have made a mistake. Like that, I bet nobody was able to do this correctly because of those mistakes. But anyways, dude, look at that! She changed the name from 21 to 24 or 24 to 21. Okay, so the real problem we were supposed to do is probably not the ones that were listed here. Like 24 is not what we're supposed to do. We're supposed to do 21, but it's labeled as 24. So I'm going to change the name to 21. Nope, not what I wanted to do. Let's see if this is in fact number 21. I believe she's intending for us to do number 21. Yes. There was a different data sheet. Or was there? I can't remember. But okay, this is probably for like the proportion one, so it took me 47 minutes to do one of those three problems. Are you kidding me, dude? This is taking forever. It's not here. Nope, it's not here. Difference between proportions. Difference between means. So, like, she originally had listed this. Yep. This is what she had listed in the problem or in the sheet before. Like, I wonder how many students actually tried to do number 24. Because I don't know, is this thing even possible to do without a data sheet? But anyways, apparently it's actually number 21. So we have house, the appraisal, and the price. Oh man. Mean difference between the appraised values and the selling prices of the houses sold in the suburban community. Oh, jeez. I have no idea how to do it. So, time to watch video.
Our mean and our confidence level. One, the proportion of crest. And again, that's also called, and people would still forget it. Increased sample size decreases standard error. Increased sample size decreases standard error, which results in a decreased confidence interval. Smaller appraised value seems.
He has it listed as 24, but it's 21. That's so funny. Like 24 is like really complicated, and I was like, there's no way I'm going to try to do this without help. So I just didn't do it.
Okay. So value in the selling.
Is she going to mention the fact that she's looking at number 21, but the file is labeled 24? Like, how do you even do? How? How? Does she even notice that?
I should just went.
Also, I can't access the textbook with Cengage. I have to use a different thing, which is very annoying to me, at least, because it's different. Because she gives different page numbers for all these problems.
Went too far now. Oh, yeah, because it's difference between two names. Okay, so a real estate agent has collected a random sample of 75 houses that were recently sold in a suburban community. She's particularly interested in comparing the appraisal value and recent selling price of the houses in this particular market. If you want to just open up PO 821 from here, that's fine. Calculate a 95% confidence.
Hilarious. I don't have access to Cengage. So, like, Am I the only person? Like, I'm literally using a different thing to read our textbook than what is shown here.
Interval between the mean difference between the appraised value and the selling prices, and interpret that confidence interval for the real estate agent. Okay. So,
And she literally knew to click on 824. What? What on earth?
looking at this file here, here's our appraised value in thousands of dollars. So it's $119,370. Recent selling price. And this is obviously paired by the same house. If you have data that is paired by the same house, we can do a confidence interval on the difference simply by determining what is that difference, and then
Calculate the difference.
running our data analysis tool pack like we did before. So I'm going to take the appraised value and subtract the price, the selling price. As you see for house number one, it's a negative difference, negative 2.5. So again, in thousands, $2,500.
Wait.
Copy that formula down. All I did.
How did you get it? Wait, how did you get it to be an absolute value, but the negative numbers are red? What? How? How did you do that?
Confidence interval on the difference simply by determining what is that difference.
What?
And then running our data analysis tool pack like we did before. So I'm going to take the appraised value and subtract the price, the selling price. As you see for house number one, it's a negative difference.
How did you get it to show up like that with that format?
2.5. So again, in thousands, $2,500.
It's not like it matters. It doesn't matter what the presentation is, as long as you get the right answers.
I saw a small black cross, and then I double clicked and copied that down.
It just did it by itself. What? Okay. Whatever you...
So some of them are coming up negative, some are coming up positive. So sometimes the selling price is higher than the appraised value. Sometimes the appraised value is lower or higher than the selling price. Okay, so sometimes the selling price is higher than the appraised value. Sometimes it's the other way around. All right. So if 0 is in this interval, then this appraised value seems to be a pretty good estimate of the selling price. There's no significant difference if 0 is contained in this interval for the difference, confidence interval for the difference. All right, so confidence interval from the data analysis tool pack, opening up the tool pack, selecting descriptive statistics, clicking on OK. For our data input range, it is column D, the difference that was calculated.
Just the difference, just the difference. That's it. We just need the difference. So, what a fun time this is. Like, where were we supposed to learn how to use the quote-unquote data analysis tool pack? Like, where were we supposed to learn that? Where? Was it in the PowerPoint? Maybe it was. Maybe it was in the PowerPoint, but not in the textbook. This is literally the first time I'm using this thing. Like, were we supposed to use this thing for like a bunch of the previous stuff too? I don't know. This is going to be this. It's gonna be
R in first row. Do not want to put it into column input range, it is column D. The difference that we just calculated, make sure labels are in the first row. Do not want to put it into column D or it will be very angry at you. So F, this I'm going to put over an F.
Summary statistics, confidence level 95%. It's probably good.
Summary statistics and confidence level checked off.
So, and we got it. There's no mode. This is such a handy tool. I never realized I could use this. Man. So.
When that table comes up, I know that I'm going to.
What just happened? She just moved to a different tab accidentally. She didn't use the autofit thing. She just did it herself. Awesome. Okay.
Our two numbers of interest again, the mean and the confidence level.
Confidence interval. Level.
To highlight these, I'm going to draw an eye to them so we know where they come from.
And
this is the confidence interval for the mean difference. And, I can elaborate mean difference between appraised value and selling price if I want.
95% confidence interval for the mean difference. I'm just basically guessing what we're doing here because this looks pretty self-explanatory, like the same thing that we did before. Equals this plus this equals this minus this. So maybe, do I even need to watch the rest of the video? I mean, it's pretty self-explanatory compared to, like, given what we did last time.
Or I want to be real specific and clear, right? Dealing with somebody that doesn't know the problem, probably a good idea to add more information than not. For the sake of time, we will be more vague and more speedy. So upper limit, as we've done before, is our mean plus the confidence level.
This would have saved me so much time if I used this for previous problems too. Like, I was using a much more complicated method to get the answer. And that looks like it's the answer I got, so.
More decimals than possibly could be useful. Let's just show you the equation again.
But we're not done yet because we have to answer the stupid question that it's asking. It's like, what is the interpretation? What does this mean exactly? So basically, the difference between the and that was a sample, right? Based on our sample, we can be 95% sure that the difference between the appraisal and the actual price will be between 1.7 and negative 2.49. That was funny, right? Oh.
followed by the two values subtracted from each other. We get this range from negative 2.49 to a positive 1.74. Obviously, that is containing the value of 0 in that interval. As a result of 0 being in the interval, that means to me that there is no significant difference between those two values. So
What?
pop up and let me take a look at the way that I would write that up. Right here, we are 95% confidence. Oh, and by the way,
We are... And we have to multiply it by 1,000. I forgot to do that. Ooh. So... negative 2,000 and 1,000, where negative means the appraised value is lower than positive values mean the appraised value is higher. Okay. Forgot to multiply by 1,000.
that to get the actual value, we need to multiply by 1,000. So let's yeah. Our value times 1,000.
Great. Appraised value and selling price. Wait, does the answer have a dollar sign in it? Yes. Dang it. Wait a minute. If you have a negative number... Oh, okay. So we are 95% confident that the mean difference between appraised value and selling price is between this and this. Negative results indicate that the appraised value is less than the selling price, and positive numbers, positive results indicate
because remember the
so I don't know if there's really anything else to deal with here.
two values, 0 is in there, and if the true mean difference is 0, then those values are not significantly different from each other. So when we go to do t-tests, if we ran a t-test in chapter 9 on this same data, we would see that these two values are significantly different from each other. Okay, so that's how t-tests and confidence intervals are related to each other. If the confidence interval shows 0 in it, then a t-test should show that they're significantly different from each other. All right. And that's a broad generalization if you're talking about confidence interval between the difference of two means. All right. The last problem is number 43. This is from the back of the chapter. It goes back to a confidence interval.
Number 43, quote unquote. Even though this says it's number 40. Oh my goodness. Yeah, she must have had 43 originally, but it wasn't supposed to be 43. It was supposed to be number 40. Dude. So we're done with number 21. Now we have to do number quote unquote 40. She calls it number 43, but it's really number 40. Yep, look at that. She renames. She didn't rename the files. She renames the links to the files. That's awesome. So, like, what is going on here? Why is the numbers wrong? Why are the numbers wrong? Who messed up? Did the teacher mess up, or is it the fact that we're using different textbooks or something? Like, yeah, the SEC, accounts receivable,